welcome to Cloudonaut. This is our Builder's Diary series, which is all about the day-to-day challenges of builders. In this issue, Peter Reitz from our partner tecRacer talks about how to build serverless ETL pipelines with the help of Apache Airflow and Amazon Athena. You studied economics, got into programming by chance, and joined tecRacer in 2017 as a cloud consultant. And nowadays, you are focusing on machine learning and data analytics. So welcome to the show, Peter.
Yeah, thank you for having me. I'm excited to be here, and I'm really excited to do this podcast.
I'm looking forward to talking to you, and even I'm more excited about the topic that we are talking about, which is serverless ETL. I failed on that topic. That's what I can say right at the beginning. So I'm very interested in your approaches on that and what's happening nowadays with that. But before we do so, I'd like to understand a little bit. So how did you grow from basically economics to programming to cloud computing to being a consultant at tecRacer? So can you give me a very short summary of how did that happen actually?
Yeah, of course. So I think it was quite an interesting journey. I finished my master's in economics and was self-employed for a few years. And then I wanted to go back into a company to learn from others. And I didn't really know what I wanted to do. And I got an application from tecRacer. So they were looking for a cloud consultant. And at that time, I had no idea what it was. So I never heard of AWS or the cloud or anything, right? And I read through that application, and I think I matched maybe 10%, maybe 20% of what they were asking for. I still applied, or a headhunter still applied for me, I would say. But I still applied, and I still got the chance to talk with Gregor. And that was a match right away, right? So I felt right at home, and I still didn't know what I would do in the end, but just the talk was great, and the challenge sounded good to me, and so I started, and I think it was the right step, definitely, and I'm very happy with that step.
Okay. So by the way, I would also love to do a podcast about economics. So this is really interesting.
Well, I would like to join. That sounds so fun.
So I did a few.
I'm always talking to my colleagues about economics, and they I think a little bit bored by now. But if someone is interested, that would be cool.
So we should do an off-topic show about economics. That would be great. Okay, but first let's talk about AWS. So we mentioned already, so nowadays your main focus is machine learning and data analytics on AWS. So that means all your projects probably have to do with huge or maybe very huge amounts of data. And I've never done a project like that. So can you maybe take me to the journey? So how does a typical project for a consulting client look like that has a problem in that domain? Is there any approach that you're following, that you have in your head when you planning a project?
So I think it starts like a normal project, right? You meet the customer for the first time, and you discuss the problem, and you think about the solution. And pretty much in the first meeting, or maybe in the second meeting, I will start to ask about what kind of data we have, what amount of data we have, how is it structured, and how is what is the expected end product? So how needs the data to be transformed that it can be used for typical analytics or maybe just a dashboard or whatever, you know. It's not so different from other projects. I think I've done now 3 or 4, which I would call big data, right? Big data, as long as a normal database is not enough anymore.
Mm-hmm. Okay, so basically you start understanding the data that is there that you're starting from, and then you try to find out what's basically the end product of all of that needs to look like. So basically, I assume that what you're getting from the customer is what they need to achieve from a business point of view. So you're probably, so that's what I imagine. You're
In the
translating
best case,
basically the
right?
data they have and
Yeah.
the goal they have from a business, and then you need to translate between all those sides
Yeah.
and basically form a plan on how to achieve that.
The fun really starts when the customer doesn't really know what he wants. I think you know this as well, right? Not all customers really have a goal in mind, and then you can start to improvise, I would say, and just present some stuff, and the customer is excited to see what you present, and that's really fun for me, because then I can be more free and not really. Or sometimes the customer is also saying we need to use this tool and this tool and this tool and so on, and then it's not so fun anymore. But when you are really free and also the expectation is not that clear, so that you can move some things around, that's the most fun I had in a project. Yeah.
Okay. So when you basically are able to design a solution that really fits into the problem domain, and you don't have too much constraints around that.
Constraints.
Yeah, that's what I know from consulting projects as well.
Yeah.
That's when you really can build with the best tools that are available.
Yeah.
Stuff like that. Okay. One typical project that you're doing is building serverless ETL pipelines. So ETL is extract, transform, and load. And so how does the architecture, or what are the tools that you're using for building such a serverless ETL pipeline?
If I can choose the tools, I'm very excited, because then I can do my preferred solution. So this is do pretty much everything in Athena, and choose the control mechanism. So who's starting those queries, and who is seeing if they finished and if they were done correctly and so on, in either step functions or in Airflow. So to manage everything, use step function or Airflow, depending on size and everything. We can talk about that if you want. And then do all the ETL in Athena, because there are 2 or 3 main advantages, I think. Everything is running on demand and pretty much instantly. So Athena is really fast, right? Even if you're going through big data, the result can take maybe 3 seconds if you're writing a good query and if your data is well partitioned. Yeah, also the transform mechanisms can run in Athena, and you can create new tables, and you can transform the data this way. And also enrich the data, which is really cool. You can combine multiple data sources, which is what I'm doing in my current project. That's really cool. Yeah.
Okay. So I think we need to start a little bit more at the beginning with that. So you are
Sorry.
excited about Athena. That's what I understand. And then we need some more, which is to orchestrate the pipeline. But maybe let's start with Athena first. So just to, I will explain Athena in my own words, and then you can go on with that. So Athena is as a service I like a lot as well. So Athena is basically a service for AWS that you can use to run SQL-like queries on data stored on S3 buckets. So that's really cool. So the cool thing about that is basically you don't need the schema in advance. You can query the data that you upload to S3. And you're basically defining the schema ad hoc as you run the query. That's very cool. And the other very cool thing is, so you can store huge amounts of data on S3. And now you have a tool to basically make use of all the data that you store in some call it data lakes or whatever, but you just dump all your CSV files, whatever you have on S3, and then you have a very simple way to basically query and analyze the data. And the cool thing about Athena, that I'm using it a lot nowadays to build dashboards, business dashboards. And the cool thing I found is it's very flexible, and you're only paying when you run a query. Basically, you pay for the data that gets processed from S3 when you run a query. So for a dashboard that I open once a day, that's very cool, because I just pay for that fraction of the time and have really great compute power underneath. So it's really a serverless product, I would say.
Yeah, that's a really important point because you only pay for the data scanned, right? So even if you have a huge transform algorithm in the background, and the query takes maybe like, I think the max is 30 minutes now. Even if it takes that long, you're only paying for the data scanned, and even if it's very compute intensive, your workload, your ETL workflow, you only pay for the data scanned. That's so huge.
And basically, the model in my mind is that Athena gets all the data from S3 in parallel. So it parallelizes the task of fetching all the data, analyzing all the data. It fetches all the objects and then basically combines the result together. And that's what I'm presented back in a SQL-like style, so like querying a SQL database. That's really cool.
Yeah.
Okay. So, but now you're mentioning that you're using Athena for ETL. And I can share a story from a consulting project that I've been working on. And I had the idea at the very beginning of Athena, many years ago. I don't know how many, but a few years ago. I had the idea I could use Athena for exactly that. So we had a huge data set with CSV files, and I wanted basically to compress the data so that at the end I don't have to go over too much data I think it was also for building a business dashboard. And what I realized so Athena is really cool. And back then, what was possible is you could basically store the output of a query in a CSV file on S3. So that was as I remember, the functionality that
typical
was
output
then. Yeah, but that was, it was not very convenient to do so. It was very hard to build an automation around that. I failed on that. So at the end, I think I built a solution for the customer, but I think we never used it because we then decided to go another way, which was more, And so now you're telling me you're building huge ETL pipelines with that. So the question in my head is, how does that work? How do you make that happen in probably a more reliable way than I've been doing it? So maybe can you talk me through that a little bit? So how does that work? How do you build an ETL pipeline with Athena?
There are two main ways to create tables, right? So you already have data in S3 and you create an external table on top of that data. That's not really the preferred way I use. The data is already in Athena, so the CSV files, like you mentioned, right? This is raw data, and you do a really quick table on top of that. That can be the external table, but then you take this table and you query it, right? You query it with a create table as statement, and then you can do all the things you can do with SQL, which is more or less unlimited, right? And you create new tables from that, and new tables can also have an output, and that is the way we transform the data. Was it clear? Or?
Yeah. Okay. So let me try try to explain how I understood what you are saying.
Okay.
So basically it means you have data stored on S3, let's say in CSV files. You define an Athena ad hoc basically table based on that data that you already
or
have.
You use a glue caller, right? That's
okay.
an easy way to.
And then basically you are running a query, and the query you run fetches the data that is already available, and it basically creates a new table based on that. And as you're using a SQL query, you now can do things like, let me imagine, a group by clause for or compressing the data. Or you could fetch, as you mentioned, query other tables, basically join them to enrich the data. And the end result, basically the result of the select query is what you then store in another Athena table. And in the background, Athena will create files on S3 to store the result for you automatically.
That's a good explanation. And what you can do, so right, for group by would be for analytics reasons, right? For dashboards, so you want to have some kind of results over all the data, but you can also do calculations, right? If you maybe have two different columns, you want to combine them in some way, or even take external data, right? So we have in the current project I'm doing. We have created another data source, which is then combined with this data source, and we enrich the data in this way. and we get way more insights.
Okay, so Peter, we talked about the create table as select statement that basically creates a new table out of a select statement. But I imagine, so for example, we are using Athena to analyze the data from the AWS marketplace where we sell some software products. And what we need to do there is every day AWS sends us a new batch of CSV files, and we basically need to add that to the table. So is there any way to do that? So basically to append data on a daily or weekly basis?
Yep, there's a quite convenient way with insert into statements. So you can use insert into and use the same data model you defined in the table, right? It has to be exactly the same because else it wouldn't work. And then you can do daily updates to your data. And for example, if you partition it that way, that you partition it by date or maybe by day even, and you get daily updates, it's really easy, right? You can also write a cleanup mechanism so that you never have double data, and you can have a very stable process that is always adding exactly that day into that partition. And Athena automatically recognizes those partitions if you do it right. And then you can just add to the table, and you get your data gets bigger every day, and you can do those daily processes, which is nearly every project needs those daily updates, right?
So you mentioned another thing that makes me curious. So you mentioned partitions. So how does so partitions are, so I know it from the good old databases. So but how does partitioning the data work with Athena? So why is that important, and how do you do it?
Partitioning data is actually important in, I would say, two ways. So mainly it is for reducing the data scanned by further queries. So you build your table, you add with a daily intake to that table, and then you want to maybe build a dashboard on top of that. And that dashboard maybe only needs the Q&A for analytics. You just want to see what has happened that day. So you write your select statement with a where clause where the date is today. And then Athena only has to search through exactly that partition. And you save a lot of money, and it also gets way faster. But I also have a story, if we have some time, where the table was over partitioned, and that was terrible. So you really have to think about your how you query the data. That's really important.
And why is that? Because so let's imagine I'm partitioning my data by date, which is probably very typical, so that I can only, I don't know, search through the last month or the last quarter or something. But when I add additional partitions, I don't know, in my example about the marketplace, I could do partitions for each product or stuff like that, or maybe even each customer. Then it gets probably really, crazy. So what is at the end the problem with querying the data? Do I need to know all those partitions to get my data, or why is that an issue?
Yeah, you don't need to know your partitions, but you need to know what you want to query in the end, or it's recommended. I mean, you will get inefficient queries, and they still work most of the time if they don't run into timeouts. But it will still work. But if you want to have it in an efficient way, then you need to know what you want to query the data by. So, for example, if we have those daily dashboards and they only want to do the day, then it makes sense to partition by day. But you could also have, let's take your example, and you will partition by customer because you heard partitioning is great, and partition by as many things as you can because then every query is efficient, right? What you will have in the end is very, very small files, maybe even one file per partition. And if you have big data, you can end up with a lot of partitions. And every partition needs actually an S3 list call. And that can actually get very expensive. So we had, I will tell the story now because I think it's funny. We had a table with additional data. So we built an additional data source and wanted to join this table two times actually. And this table was partitioned in a way over partitioned, that it has had one file for each partition, and in the end it was 80,000 files. So actually not even big data, but way too many partitions. And we joined this table in an inefficient way. So we also did some errors, but and then we ended up with a lot of S3 list calls, which would get into the thousands actually for a full calculation. So if we want to recalculate everything, and I was curious, why is this happening? I thought I knew that Athena was making S3 reads and get a get object and list actually, and it does a list for each partition, which is quite logical because it needs the files, right? It needs to know what is there. And if you have those over partitioning, it slows down the query a lot. You get this new, it's also a new feature of Athena. You get those query details, and there you get the time planned. And the time planned will take very, very long if you have a lot of partitions. That's a disadvantage. And you also will get huge S3 costs in the end, which is not necessary. Really think about the partitioning. And now we ended up with doing less partitions for our main database, for our main table. This is a little bit more S3 Athena cost, but a lot less S3 cost in the end. So it's really interesting to balance those two.
So I'm currently very lazy with the data we're getting from the marketplace that I told about before, because I don't have any partition at all, because the format is very clumsy. But that means each time I run a query, it has to load all the data from the bucket, right? So that's also, it's not a big issue because the data amount is, I don't know, a few hundred megabytes. But over time, this will grow and grow. So I need to think about a solution in the future. But yeah. So basically, what you're saying, or what we can get out of this is, you need to think about the partitions. It's important to have partitions to query data effectively, but it's also important to not overdo and have too many partitions in place, which will just increase the cost for listing the buckets. And this brings me to another aspect. So we have talked about the Athena cost structure. So you pay for the data that gets processed. How do you monitor the costs for your S3 access from Athena? Is there any, I don't know, because I think, so as you mentioned, so this looks like I can basically, it can have big consequences if I do it wrong. So do you have any, do you typically set up some monitoring for I don't know, a budget or something, or how do you make sure you're not running into any issues? Is there any good approach that you have?
So I haven't found a really good way. What I'm doing right now is monitoring the cost explorer of AWS really closely. This is quite a helpful tool because it, at least for the last day, it's really accurate. Sometimes it can change a little bit by cents, but it's really accurate for the last day, not for the current day. You can also enable S3 logs, which gets expensive as well if you have a bucket with huge amounts of transformations and all the time there's data queried and so on. So you have to be really careful with that. But you can look into that and see if you have way too many S3 list operations. And that's the same, right? You can query this table with Athena, this data with Athena, right? You can enable S3 logs, build a really quick Athena table, and then have those logs available and do really quick ad hoc analysis. So
that's a very important learning. So if you use Athena, you should not watch only your Athena costs, but also watch your S3 costs, especially if you process lots amount of data. So we talked now about Athena, and I think we both really like the service. That's what you really can tell from what we've been talking through. But the other way to solve a similar issue would be using EMR, so Amazon EMR, to spin up a cluster and stuff. So have you used EMR as well in the past? Can you tell me about the differences and why you mostly prefer Athena? Is there?
Yeah. So when I get into a project, most of the time the customer already has something. They started with something, right? And they try to do it in any kind of way, and then they ask for help. And what they mostly do is launch an EMR cluster and start deploying some scripts, and then they take a long time, and also the cluster is unstable and so on. And now I come into the project and I look into that and I try to fix it in a way, because let's say the customer wants to stay with EMR because he's familiar with Spark and maybe wants to write Python jobs therefore. And what I found a little bit annoying about EMR is that it's even if you scale it up only if you need it, right? So you can write scripts and start the EMR cluster only if you need it. Even then it gets really expensive, because to do the same operations we do now in Athena, you need a really big cluster. So if it's too small, it will fail and it will get unstable, and the scheduler will get overloaded and so on and so on. And the worker will not perform anymore. And to fix it, you can log into the cluster, but it's also complicated. Developing on that cluster is also kind of complicated. Where in Athena, you just execute your SQL, and if something fails, you can correct it and develop that way, right? And in EMR, you upload your jobs per EMR steps, and then you have to look into the cluster and get the logs out of there, and it takes a long time to get those logs, maybe up to 5 minutes. You can log onto that cluster, but then you need a connection, and most of the time it's in an internal network, so it's a little bit difficult to get access to that. So there are a lot of things I don't like about EMR, but it works. Okay. I mean, it still works, right? It does its job. Mm-hmm. It's just expensive and takes a little bit longer than,
Yeah, from what I get out of your description is it's more expensive, and also it's far more complex. So the whole system is really complex. And so having a simple, slim solution with Athena is probably the advantage here. Okay, so at the beginning you described basically the architecture of the serverless ETL pipeline, and you mentioned Athena, and the other thing you mentioned was Airflow. So I'm very curious, what is Airflow and how does it work? What do you do with it? Can you give me a short introduction to what Airflow is doing here?
Yeah, so Airflow is an open source orchestration tool. And what Airflow consists of is different tasks, and those tasks are DAGs. Those are direct acyclical graphs. And what they do, so they are, in my case, they are just Python code with different tasks and commands. And there's a little bit more than just executing the Athena statement, right? So I just mentioned before the S3 cleaning, so to avoid doubling of the data. So you don't want to have one day 2 times. And then we also do some kind of really ad hoc reporting, for example. So if the task is, if the daily process is finished, we send out an SNS email. And there's also some kind of reporting, so we have some quick insights into the new data, and that's just some possibilities what you can do with Airflow.
In my head, that sounds like Airflow is basically like GitHub Actions or like Jenkins, but for ETL jobs. Is that maybe a good comparison? Because basically you have a workflow that you need to implement and orchestrate, and you're using the tool to make that happen, basically a workflow management system. Yeah,
I think you can compare those, yeah.
There's an AWS service for that, which is with a very crazy name, Amazon Managed Workflows for Apache Airflow. And I can share some insights on that. So the for Apache Airflow is basically, there's a reason for that. That's exactly the way the open source project with Apache license force you to build product names when you build a service out of that. That's why this is a crazy name. Okay, but it doesn't matter. So the good news is there's a managed service by AWS. You can spin up Apache Airflow. I did so to play around with Apache Airflow a few months ago. And yeah, it spins up the infrastructure that you need, and then you get basically a web interface that you can log into. And what I played around a little bit with it, and I uploaded this direct isocyclic graph. And basically you do so by uploading it to an S3 bucket, and then it takes a little bit, and then it becomes available in Airflow. So is that also the way you interact with Airflow? So if you're building such a pipeline, so how do you get your directed acyclic graph to Airflow? So how does that work? Do you have any automation or?
Yeah, we actually have automation. I mean, you could also work with it. Just write your stuff locally and then upload it to S3 with a really simple command, right? That's pretty much what all the automation is also about. But you can do more fancy stuff, and we did more fancy stuff. So what we do now is it goes through a whole pipeline, and then there will be an image built with the current Airflow version, and all the requirements will be loaded into that. And then we do some testing, and we also do some other things. So is it formatted well? Does the current requirements, which are all required, can they work together? Just a simple build test. And then write the testing so we write testings on the DAX, and then they will execute it. But right now they are really simple, but you could do a lot more.
Okay, so that basically means the directed acyclic graph is basically treated like software, and you're building a deployment pipeline for that really with tests, and basically it seems like an integration test, and that's really cool. Oh wow, I didn't expect that. Okay, I just thought you're going to the console and uploading your S3 file. But that sounds.
In
really
the end, when everything passed, right? In the end, it's just a simple AWS S3 copy. So that's still there, but there's a lot more around it.
Basically the quality is checked before you deploy it. That sounds really cool.
Yeah.
Okay, cool. So there's one aspect of Athena that I want to ask you about. So I usually start with CSV files. That's basically often the input. And then I noticed when I had a look into Athena and played around with those create table as select statements, you can define different data file formats. I hope I pronounced it correctly. It's Parquet or OCR and a few others. So can you talk me a little bit through what that is about, because I didn't understand that part 100% yet.
Yeah, and also Avro is a really popular format as well. So it's really important to choose a more efficient file format for your data. So CSV is not column-based, it's line-based, and Parquet is column-based, and that allows Athena to, even without partitioning, search through the data more efficiently. And also Parquet is a lot more compressed by default, I think. I'm not sure about that, but we use an additional compression, which is called Snappy. And then the files also get a lot smaller, which is really nice. So I think 200 MB CSV files can be shrunken down to 10 MB with Parquet, and the same data is still in those files. That's a lot, right? Even without partitioning, Athena doesn't have to search through all the columns every time, depending on how you write your query, and if the where statements make sense.
Okay, so that's so I think it's probably a very similar concept that I know from Redshift, which I think the concept behind Redshift is also that it's column oriented and not row or line oriented, like maybe a CSV file or a normal SQL database. And as far as I understand, basically the thing is, if I do a select and only select a certain amount of columns, it has to go only through the data for that columns and not load the whole row, the whole line for basically each item in the database. Okay, so that's probably a similar concept with Redshift and here with those Parquet and OCR. And what was the third one?
The third one is Avro. That's
Avro.
also a really popular format.
Okay,
It's used in Apache Kafka or something. Maybe you've heard of those.
And those are all supported by Athena out of the box, or is there anything needed to? Okay. Wow, very cool.
Yeah.
Okay, so we talked about Athena. We discussed Airflow, and I remember one thing that you mentioned at the very beginning. So you mentioned step function as an alternative to Airflow as well.
Yes.
So what is I've used step functions a lot. So Michael and me, we use it for most often our serverless applications, stuff like that. So, but how? What's maybe the difference between Airflow and step function, and is there a reason for using one or the other tool?
So they both do the same, but there are huge differences. So step functions is actually serverless, and it's a service of AWS, and it's only available in AWS. Some customers still care about that, sadly. And Airflow is open source, right? You can launch your Airflow cluster, although it is a lot of work locally, or you can launch it in another cloud. That's a huge difference. Step function is a lot cheaper because it's serverless and only pays you only pay for each step. But you have to do a lot more work to implement all the convenient features Airflow gives you. So Airflow also has included monitoring. Airflow has some cool features like catch-up, where you can set a start date and Airflow will execute those jobs up to that start date automatically. That's really cool if you want to recalculate all your data. Sometimes you have to do that if the data model changes and you want to start fresh. And there are a lot of other cool features Airflow offers. For example, monitoring, right? So you have those cool. You also built an Airflow cluster, right? And you looked into it, and you get those cool graphs, and you get those. Each step lights up green if it's finished, or it lights up red if there's an error. And if you have a lot of ETL stuff and a lot of ETL workflows, I would say Airflow is the better choice because it brings so much more to the table, but it also costs more. And some things are also a little bit more difficult. So, for example, handing over variables is very easy in step functions. You always get those outputs, and then you have an input, and you can just take if you know how to manipulate those paths, you can just input it into the next step. And with Airflow, I struggled a little bit. Could also be me, but I think it is a little bit more complicated to hand over variables. And you have also internal variables. For example, the queue date is an internal variable, or the execution date is also an internal variable. And you have to handle those.
Okay, basically what I get from your description is that so step function is more a general tool for all kinds of workflows, and Airflow suits a little bit better for data analytics, ETL workflow, stuff like that.
Yeah, that's true as well.
Seems to be a little more focused on that. Okay, but are you still using step functions from time to time to build ETL pipelines as well?
Yeah.
Okay.
I actually like step functions a lot because they also improved step functions a lot in the last few years, even the last few months. There are nearly all API calls now as easy functions already integrated, so you don't have to use Boto or another tool. They have their small little icon, and you can just click on them and define your input and define your output and so on. So it's really easy for people who can't or who are not that familiar with programming. Sometimes you still need a Lambda for some things, but that's becoming more and more less and less as they develop these step functions.
And maybe let's see, maybe in the future they also go a little bit into these ETL directions, so they could implement things like those backfilling as well. So that would be cool. Okay, so I have now a new project that I want to build. So my goal now, after you've explained all that to me, is I will try to build a ETL pipeline for our marketplace data with Athena and step functions. I think that would be really cool to improve our dashboard and our analytics. So whenever I have a question, I will give you a call.
Oh yeah,
if I struggle with that.
I really enjoy
really cool.
doing those projects. So people still outside the company still ask me for Athena help, and I'm so happy to help because I enjoy the service so much, and it's like free. I do it in my free time because it's fun to me, right? It's like some people have more, I would say, other hobbies, and I have Athena.
Okay. that might be a very cool niche to focus on, Athena.
Yeah.
Very cool. Okay. I think we really talked a lot about how to build ETL pipelines in a serverless way, which I think is a very cool approach and a very modern approach as well to do things like that in a cool and also cheap way. That's I think important as well. Let me come back to the very beginning of our conversation. So I asked you about how does a typical project look like for building such an ETL pipeline and a data analytics project. So coming back to that, so what aspects of building an ETL pipeline are most fun to you? Which parts do you enjoy the most? Is it, as you said, the Athena queries, or is it to see that, I don't know, huge amounts of data going through the pipeline, or what basically excites you most about those projects?
I think it's all those things, right? All the things we mentioned, that it's not well known, I would say. Not a lot of people know that you can do all your ETL stuff with Athena, and I think that's really cool. And it feels like a cheat code, really, because only the data scanned is what you pay for. So even if I have a really complex and long running query, it's only the data scanned. Why is this possible? So this is really the cool thing about Athena for me. And building those ETL pipelines, I think, really enabling people to work further with the data. Let's say that we have machine learning specialists or data scientists or whatever, and they want to work with the data, and they struggle a little bit because it's not so well organized, and there's some important information missing, and I think that's a really important part of building a stable and efficient ETL workflow, which is easy to understand also. For if right, as consultants, we are not forever in the project, and some people in the company need to take over. And the way I build it is also really easy to understand and hand over, and to explain to someone, here is your SQL statement, and if you know SQL, you can really easily fix it, and all the pipeline around it is also easy to understand because of the stuff that Airflow or step functions offers. So you have those graphics, right, which are easy to understand which step is after the other. That's what I enjoy, and the best thing is if people use it and use the data, right? So sometimes you also mentioned this, you build something and then it doesn't get used. It's a little bit sad. But when you have a really efficient way of doing it, and you can present what is possible, then the chance of it getting used is way higher.
The best output would be that you really create a huge business value, because now the data that was lying around and no one could make any sense of now is really helpful to make decisions or to solve problems. So that's could be a very huge impact on company or even society. There was one question that came to my mind, because at cloudonaut, one of our goals is always to dive into the limitations. So we talked a lot about, oh, that's so cool, the solution is the greatest on earth. So is there anything that you struggle with when you build an ETL pipeline with Athena?
I think I have two important limitations. So you can execute Athena queries in parallel, but there's some magic in the background which allocates resources to your account. I'm not really sure how it works, but you can run out of those resources. And I think you can now increase your service limits a bit. So for CTIS queries and other queries, but there's still a limit, right? So if you have Let's say you start a full recalculation of one data set, and another colleague is working on something else and is also querying a lot of data at the same time. Then it is likely that some of these queries will fail due to service limits or due to timeouts, or they will stay a lot longer in the queue and you will get a lot worse performance. This can happen.
Okay.
Yeah, and another thing would be the Athena timeout, right? That's a very obvious thing. So if your query gets too complex, if you have too many joins and too many different raw tables, too many CS3 files that need to be loaded into this query, then you can run into timeouts.
And the timeout is 30 minutes. Did I get that correctly?
I think it's 30 minutes, but I think it can also be increased. So one time, it's a little bit longer ago, we increased it from 15 to 30 minutes, but now I think the default is 30 minutes. I'm not so sure.
Okay, doesn't matter too much.
You can definitely work with the AWS support on that. Yeah.
But is it then the same as with Lambda functions, that if you reach the limit, what is the solution? Is it to try to slice the problem into smaller slices? Is that basically how you do it? Okay, so I don't know.
Most of the time, you write a more efficient query. That's the start. If your query takes 30 minutes, there's likely something wrong with it, or you're querying way too much data.
Does that mean with Athena, you can basically use the same approach that you do with Lambda, that when the problem becomes too big and it doesn't fit into the timeout, you just slice it into smaller chunks? Is that how it works with Athena as well? And were there ever a problem that didn't work like that you couldn't slice smaller?
Yeah. So you can do that, actually. You can even do that within a query with additional with statements. So you can, depending on your SQL skill, it can get a lot faster. So if you write a really efficient subquery, and then you will have less joins and you can solve some problems like that. You can also do something like have many small queries and then join them all together, or union them all together in the end. That can also work. So there are multiple ways to handle these problems. And the last part of your question was if I ever encountered something where it didn't work. Actually, yes. We had a case where we had a huge SAP database which was downloaded to S3, and in SAP databases there are some tables which are really huge and others are really small, or most of them are really small, and you only have one or two that are really too big, and then even too big for Athena. And they had so much data in there. It was a really big company, and we couldn't get it to work within the timeline, even with the more efficient queries and everything we did, because we also had the problem that it needed to order the data, which is always a huge problem because then you need to load all the data into the memory. So ordering is always terrible. If you can avoid it, or if you can do it later on, maybe, offload it from the really big transform query.
Okay, cool. Thanks for sharing. So now this is really a cloudonaut approved solution. So we also talked about the limitations of serverless ETL pipelines, which is, I think, important to know. But I think I'm really psyched about this way of building ETL pipelines. There's one more thing to mention, Peter. So there is an open position at tecRacer. So tecRacer is looking for AWS cloud consultants with a focus on machine learning and data analytics. So that's basically your future colleague, right? So if that's what we discussed today, if what we discussed today sounds interesting to you and you want to do similar things on AWS, you should check out this open position from tecRacer. You will find a link in the show notes. tecRacer has offices in Hanover, Duisburg, Frankfurt, Hamburg, Munich, Vienna, Lisbon, and Lucerne. And so check that out, join them to build great stuff on AWS, and join Peter and his team. It was a great pleasure
join me and my team in Hamburg.
So you're located in Hamburg. That's cool.
Hamburg
Okay.
is the best standard.
The best location
Yeah.
is Hamburg because that's where Peter is. Okay.
Best location, yeah.
Okay. So, yeah, it was really a pleasure to talk to you. I learned a lot about serverless ETL pipelines. It was great fun. Thanks for sharing all your insights. Yeah, this was really learning from practitioners, learning from builders. I really enjoyed that. Thank you very much.
Thank you for having me, and I really enjoyed the talk as well. I had a lot of fun. Let's do it again.
Yeah, about economics, right? You mentioned that.
Yeah, right.
Okay. Bye, Peter. This was great. Bye.
Bye.